Part 2, ADC process accuracy. We talked about the sampling rate earlier and the resolution bit. So just to refresh back, sampling rate means that the number of samples that we take in the whole signal. Resolution means how we represent the value of the signal in bits. So when we talk about sampling rate, what we mean is based on the number of steps required to convert the process. The higher the frequency of the sampling rate, the more data we are going to collect. And the higher bit resolution is, the much more accuracy our signal is that we're going to get. So sampling rates are the data rate, and the resolutions in bit rate, in bit depth, or the resolution means that the accuracy of data taken. So higher sampling rate and higher resolution rate means that we are going to get a much more accurate and much more true to the actual signal that we want to have. So now, next, ADC application. For the ADC, there's been many applications for the ADC, especially the use of analog to digital in plenty of applications such as microphone, strain gauge, thermocouple, digital meter, and etc. I know that I'm only listing down 4, but there's plenty of other applications. Let's say your thermometer. Even your handset now have an ADC, analog to digital converter, to convert your voice, to convert your sound audio into digital format. Especially nowadays that most of our devices run on digital. Okay, so ADC seems to be the gateway through to communicate between the actual world and the digital world. So interfacing the ADC to the AT51. So our class is an interfacing class. So we are going to interface the ADC to the AT51. The analog to digital converter form a very essential part in many embedded projects. Interfacing an ADC to AT51 embedded controller seems to be the logical thing to do if you want to run your project. So let's go through and see how do we interface our ADC to the AT51. For our application, we are going to use the ADC 0808. It is an 8-bit processor, 8-bit ADC, successive approximate analog to digital converter, means that the bit resolution is going to be 8-bit. So the value of from 0 to max is going to be represented by 8-bit. The feature of the 0808 are differential analog voltage input. The max voltage conversion it can do is from 0 to 5 volt input voltage range with no zero adjustment, built-in clock generator. Reference voltage can be externally adjusted. This externally adjusting your voltage reference is a good way to go, because you will never know what type of voltage input we are going to expect. So it's better to have an external adjustable voltage reference, and convert smaller analog voltage span to 8-bit resolution, and etc. This is the ADC voltage reference divided by 2. That means that whenever you have a voltage reference, you need to divide that reference to 2, to the input voltage divided by 2. Let's say you want to measure from 0 to 5 volt. From 0 to 5 volt is an open. You do not need to put any voltage at the voltage ref. But if you want to go down to measure from 0 to 4 volt, that means you need to adjust the voltage reference to 2. So What it means is, whatever the reference you use, depending on what input span voltage that you're going to use. This later on will be shown from the table after at the next slide. So voltage reference to the pin is usually connected to the output voltage span. It's left. Okay. So sorry, the voltage reference pin are left open if you want to use the if you want to use the ADC at its full capacity of conversion. That means if you want to measure between 0 to 5 volt, you open VREF. That means you do not connect any supply to VREF. VREF is left to be 0. Oh, sorry. And then the step size is going to be the maximum voltage divided by the number of bits, the decimal resolution of the bit. So here we have 5 divided by 255. That means 255 is representing the 8 bit. If you remember correctly, 8 bit is equals to 255 in decimal resolution. That means one step of the sample is going to be 19.6 volt. 19.6, actually this is millivolt. I'm sorry, I forgot to put millivolt here. Have a look. Okay, so let's see the table that shows the conversion level. Okay, here you have VREF divided by 2 at pin 9. Pin 9 if you use the ADC 0804. For our application later on, I'm going to use 0808. So it's going to be a different pin number. So now, if you want to use, like I said earlier, the input voltage bands, this is the range of input voltage given in your input. And this is the setting of voltage reference. Okay, considering the input voltage, we change the value of voltage reference to cater the step size. Let's say I want to measure from 0 to 5 volt. 0 to 5 volt, I need to left open my VREF so that, sorry, I need to left open my VREF and I can measure from 0 to 5 volt. So if I measure 0 to 5 volt, 5 volt divided by 255, that means I'm going to have 19.6 millivolt per step. Every bit changes in 19.6 millivolt. If I'm going to measure for 2, I put 2 volt in our VREF, change the value of VREF to 2 volt, and then I can measure from 0 to 4 with the voltage step or the resolution step is going to be 15.69 millivolt per step. So also for 0 to 3 is going to be 11.76. If I want to measure from 0 to 2.5, I can change it, the VREF to 1.28, and the output the step resolution is going to be 10.04 millivolt per step, and so on. Okay, later I will run the simulation so you guys can see the changes if we change the VREF and the input voltage. So step to converging for converting the analog input and reading the output. So we have to follow a certain step to make sure that our chip or the ADC chip will work correctly in its procedure. So what the first thing you need to do is make CS low, and then send a low to high pulse to write or start depending on the chip you use. If you use 0804, it's write WR. If you use 0808, it starts pin. The pin is called start. Okay, and when you give a low to high pulse to this pin, the conversion will start. Okay. Conversion means whatever the input, the analog input come into the ADC chip, it will start converting it to digital value. So, and then ALE and OE is set to high. ALE stands for excess, sorry, I forgot. Later I will find the reference back. Okay, and then OE is set to high, also for free run. That means if you want to make the ADC chip run as free run, you also need to set it to high. And then keep the interrupt, or EOC, means stands for enable end of converting pin high. When end of converting pin will be 1 if the conversion is not finished. If the conversion is finished, the end of conversion pin will be low. So as long as EOC is high, that means it's telling the microcontroller that the ADC is still converting the analog signal to digital. So we cannot do anything until EOC is low. So we have to wait for EOC from high to low, then we can adjust the conversion, tell the ADC to convert another data. If the conversion is not finished, okay, the EOC equal to 1, usually we will do it in a pooling method. So that means we will pull the microcontroller on EOC pin. So as long as EOC is equal to 1, we will not run the program, we will not read the input from the ADC. Okay, if the conversion is finished in EOC equal to 0, okay, we go to the next step. The next step is to make CS chip select equal to 0, and then read the conversion from analog to digital to our microcontroller. Okay, hopefully when I run the simulation, it's much more clearer. Okay, so the ADC that we are going to use are the 0808 IC. It requires a signal of typical 550 kilohertz. You can always give the conversion signal from an external output, or you can always run it by using a 5.5 timer, or using a RC circuit to generate the pulse. Okay, so in order to visualize the digital output, so usually to test run this chip, the ADC chip, we will put in 8 LEDs to the output pin of the ADC chip and see the conversion from analog to digital. Okay, just directly from the ADC without the use of microcontroller. Okay, next. So this is the chip itself, the ADC 0804 and the ADC 0809 or 0808. Both of these chips actually works the same way. However, the difference between 0804 and 0808 is that the 0808 is a 8-channel ADC. That means the ADC 0808 have 8 channels that can be user select. We can select the channel for the ADC 0808 by giving the input at A, B, and C pin in our microcontroller. We can give A, B, and C pin certain bit value so that we can select from 0 to 8 channel. So whatever channel we select, that is going to be the input channel that is going to be converted into the digital and transferred to the microcontroller. Okay, so here's some reference use before we go into our protest simulation.